Hello, guys, and welcome to another stream. And yeah, today I was thinking on starting on a project that I've been thinking of doing for a long time. Let's make a programming language. It will be a fun journey. So let's get started by creating a small project from where we can then start doing stuff. Yeah, so I'm thinking of using WSL Ubuntu for now, and we'll see as we go along. Yeah. So, yeah. So, I was thinking as to what we can name it. I was recently doing some experiment on making some small operating systems. That topic for a different video, maybe. But yeah, today we will focus on creating a new programming language and just thinking what we can call that. And I'm not good at naming, so we might change the name. But for now, let's go with what do we call it? Uh, how about Sparrow? Yeah, for now we can call it Sparrow or whatever. So yeah, we have Sparrow here. Let's go inside. And yeah, let's make some folder. So maybe one for the source code, maybe so src, one for the examples, eh, maybe one for where all our compiled code might go. So maybe bin. And yeah, that will be, I think, nice. So let's create a small make file maybe. So I don't know. Maybe, or you can create a like shell script file as well. Uh, let's create a small make file maybe. Right. And for now, all it will do is it will just compile our code, whatever we have in the source directory, and we will put the output in like maybe bin slash swallow. That will be the compiler, essentially compiler interpreter. I don't know what we will go through, but yeah. And then we might need some flags. So first of all, I would really like to use C++ 17 at least. So let's go with that. Right. Um, so if, for example, we add a main.cpp, something like that, right? The main execution point. Let's see. something like that maybe. And we can let's try to compile this. There's a- Yeah, so we got some error. That is, I think our make file needs to be have C++, not C+. And if we make that, I think it compiled, right? If we open bin, we have swallow here. So maybe after compiling, what we'd like to do is run it. I don't know. So maybe something like right. So if we make this now, we get this output, right? And that's a good place to start, I guess. Okay. So first things first, maybe we will need some example code, which we will then parse. So basically, when creating a programming language, there are a few steps. You can skip some, but generally, what people do is they have your source files, right? Then that source code itself is fed to something called as a Lexer, which basically converts that source code into something like a series of tokens. Now, these tokens, then we can basically feed to something like a parser, which will give us something like an AST. From there, then we can basically start executing the AST if we are making an interpreter. Or if we are making a compiler, then we can generate some sort of IR, intermediate representation. From where then we can create some reasonable assembly. And then we can translate that assembly into some machine code maybe or executable. So yeah, that will kind of be the way we'll be going, I guess. So first we'll start with Lexer. But for that, first of all, we will need some actual source code to get started with. So we'll need to load a file maybe. So let's start with that. So we'll call this maybe demo.sw because we are currently calling our programming language Swallow, right? Uh, yeah. So I think we have demo.sw and it will be kind of like C++ or C like this. So my goal is to like at least get a language that is like C and then keep on adding features on top of that. So and make it a unique language by itself, but still like when people try to use it, if this gets to some stage like that, then yeah, they might like it. For example, we have let's say a function add which takes two integer maybe a and b and maybe it returns a plus b, right? Uh, if let's say a is less than 0 or a is greater than 0 maybe. This is just for getting the parsing in place. Otherwise, or maybe in this case it will just return a, right? And you can add some spaces etc to see if things are looking correct. Then maybe we have int x equals to maybe 10 and y equals to 20. Then maybe string apple equals to say the string, and then maybe result equals to add a plus x plus y times x comma x, maybe maybe print add the results and x, right? So this should be a good chunk of code that we might want to parse, right? And create a series of Lex tokens out of it. Yeah, maybe add some comments also. So this is a comment, right? So yeah, basically let's get some support for these things. Maybe we can have some other data types as well. For example, let's say float equals to 10, maybe point zero, right? So we have decimal numbers and integer numbers, strings, and these things, right? And I can go on as we progress. So yeah, let's create in our source a file called Lexer, but let's first create a utility file that basically we might use to store our all the like generally used functions, or maybe something like that. So utils.cpp, or you can go the header only style also. In that case, I will need to write less code, I guess, a bit. But in a production level code, most likely you will not go every file HPP. Right. But anyways, we can look into those things later. For now, let's have you maybe, and let's have a function as string or loading some strings, and let's have a namespace. You can call this as W transfers to hello, I guess. I think I should reduce the sound a bit so that it's good. Yeah. So first thing will probably be to load this demo example, right? And you can get working on that. So essentially, we'll have a struct. Not in the utils will first load the file. So just a string called load file, or you can just use this whatever as string. Right. So yeah, not that. And it will essentially load a file as a string. Right. You can make this as static. Yeah, so that works, I guess. We can write the functions here, or we can just declare the definitions on top, and then we can have the function bodies as well. We can go for that. I don't know. Let's try doing that once. So maybe here we our basic definitions will stay something like that. So then maybe here our implementations are right. So std. I don't know if this will compile. I never tried with static functions like this. Like I have used static functions, but like in header files declaring static functions on top and then like this. But it should ideally work, right? Because at the end, header files are just copy pasted when you use hash include. So let's see. We'll probably take a file path, I guess. Right. And yeah, so maybe something like that. file content, and at the end maybe we'll return this file content, something like that. So then we can maybe have something like a file pointer, right? Then I can say if open underscore s, maybe. Is it available here? What does it say? Okay, so it likes f open, but it will complain with f open basically. So I don't like that, but still you can go for that. So f open basically opens a file. In this case, that will be your file path, right? So you can have it here also, maybe. So and a flag on how it should read it, right? So in this case, we're just reading the file, maybe in binary. Don't know. And once we have opened the file, right, we need to know like how big that file is. So maybe something like what does LG does. So yeah. So most likely after we have opened the file in read mode, our cursor will be at the beginning of the file, right? And then we might want to go to the end of the file to get the length of the file, maybe. So we can do that. Yeah, I can do some search on Google and try to figure out. So file P, maybe mm, LG. So basically LG. Uh, 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 does what? It is the method. Let's see. So is there no doc? It returns a pause type, right? Yeah. So for example, for this hello, right? LG is returning 6 maybe. So we can leverage that. Don't know. So we might want to FC to our file to the like F end or something like that. I don't know. What is it called? There's something second. Yeah, that would work, I guess. And then let's say we have something like file size. So file size is equals to basically f tell, right? And here we pass our file pointer. Uh, what is f6 saying? Okay, no function call to no matching function call. Does it take pointer to this? You can check it actually. Yeah, it takes a pointer, I guess. Okay, so it also takes a 0, which is it denotes the starting of the file, and then the cursor, right? So yeah, that makes sense. So it takes a 0 here, basically. And also you don't need this, right? So we can just check what the content was. Right, to get a feel that whether it's loading or not. right? And then we can go to our main. I can include this thing, and I can call this thing uh, file string, and we have a file path, right? So we'll have something like a const char star file path, which is for now is just we'll create art cursor kind of thing later, but for now, example slash demo dot sw. Why not, right? And if we just do that and make this, will it get make? Okay, so didn't fall. Yeah, so we are getting 266, some number, right? So, yeah, next stuff we might want to know like what will be the how can I create? Let's just open ChatGPT, why not? Right, and let's ask oh, string with size. Yeah, so we can do that. Let's do that. Why not? So let's go in load file, and basically this file content right here, right? It will be like all zeros with the size of file. So maybe file size plus one, just to have some extra area, and it will be all zeros, I guess. Right. And in this case, we might also fail in loading the file. So maybe something like if not FP, then I don't know like if open returns a null pointer or not, but still maybe returning an empty string, and I can say that we'll need a proper error logging, but for now we're fine. Something like that, right? And then once I have this content, I would need to read that many bytes, right? So before that, I need to go back to the beginning of the file. So maybe f6, uh, fp0, and it was called sick end. So this will be six begin or something like, I don't know, not current obviously. So six set, I guess, is the beginning of the file, right? And then we need to read, right? So yeah, f read, right? And the first thing is like where to read, right? So our file content should have some buffer where we can read it. I don't know where. Does it have some data? But is it constant? So it should not be constant, right? Don't know. And second parameter is what was the signature of a read? So it takes the pointer, the size, and then n, right? So size in our case we like read 1 byte at a time size, and we have total file size, I guess. And we're reading from our file, maybe something like that. And if it is complaining, so yeah, it wants a void pointer, but I'm getting a const charster, so you can ask ChatGPT. One trick I am thinking that will work. Yeah, but I don't want a const charster. Yeah, so yeah, we can just do this, right? This makes more sense. So maybe address of uh, file content 0, right? So at this point of time, we should be good to go with opening editing the contents of the file. So we can if close the file maybe. So and we can return the file content, right? And if that works, right? So I can have something like that. And then you can actually print the content uh, file content dot system, right? Just to check. So yeah, if we do that, we get the content of the file, right? We got the entire file. That's nice. Maybe we don't need to print the file size anymore. So you can keep that closed. And basically, we know that this is the file size, right? Because we can just ask, right? For example, something like that. Um, file content dot size, right? Or length. I think in string it's length. Don't know if the music is very loud or not. I'm hoping it's not. Can make. Now we need to make twice, but we'll get that fixed. Anyway, so yeah, we get one character more, right? So whenever we are talking about file size, it's basically this. That's I think like even file size. So now that we have the whole file as a text string, right? In a string buffer, we can get started working on our Lexer. So let's create that. We can call this lex.htt or something like that, which will essentially be our Lexer, right? And we can open this maybe somewhere here, and we can get rid of this, right? Mm, yeah, we can move this a bit down and something like this, right? So yeah, hash include. First of all, we need pragma once, so that if we're including this in multiple files, it doesn't cause any issue. So yeah, and then obviously we will be working with we'll be taking a string input, right? But I don't want to create a lot of strings for every token. I don't want to create a new string, right? That will be actually a waste of memory. So maybe we can just use string views. I don't know. Yeah, we might want to have a vector, but I don't know. Get started with that, and maybe then name space SW, that is the namespace of our project. And here we can have our definitions. Then somewhere below, right, we can have our implementations. So I just want to keep things a bit clean, that's why. So first thing is we'll need some kind of type, right, to like tell that this particular word is, let's say, identifier, or this is a string, that kind of thing, right? So maybe we can have a enum and call it token type. Maybe it might have some values like tk mm, id for, let's say, identifiers, and tk str for, let's say, strings, and maybe tk int for integers, and tk float for numbers, right? So let's open that example file, and let's see what kind of tokens we might want. So yeah, we also need to have some kind of entity node, right? So we can have that. We need to have that also. So tk, and we can call this end statement, maybe. And what else? We might need a tk operator to tell that, okay, these are the operators, and I'd like to have operator before end statement. I don't know why. That's just my opinion. Then finally we have something like tk and token type to just have a guess if needed that how many types of tokens are there. Is this how we define a number? I forgot. But most likely yes. So with that we can have our basically token. So token underscore t, right? And it will be better if we call it Lex token, because we might have different types of token in different uh, pages. So, and this token will basically have the token type. So token type, and it needs to have that content, right? That particular string or string view in this case. So string std string view uh, value, maybe. Yep. And for we can also have a invalid, right? So right. So that works. And then the type can basically start with invalid, right? Which is basically zero in this case, I guess. And why are you crying? So yeah, that's the compiler using some old version of C++ to say that string view is not there, but it's there. And I can initialize it with an empty const character, literally, right? character pointer. But yeah, let's. I think we can get rid of at least that annoying underline. So maybe uh, compile flags. I don't know. We'll ask ChatGPT if this is the correct thing. But in compile flags, we can basically say that we're using std equals to c plus plus 17, right? And does that solve the issue? That is the question. Uh, I don't think so. We definitely don't want to do that. Let's just close everything for once. And let's open this. So if we open our Lexer, right, you can ask ChatGPT, but it's something like compile flags, if I remember. So they call it flags.txt. Yeah, compile flags, I guess. So yeah, let's do that. Uh, so we are calling it right, PIL, FLIGS, right? Just to check for one compile flags. You can use client ID. I don't know. Uh, but the spelling looks right. Right. File name compile flags. So we have already created a file name compiled flags, and we have put this information also that the standard C++ 17. So ideally it should pick. Why is it saying that it's still choosing to look into an old C++? That's what is. Just spell something. What are you making, bro? Yeah, I'm working on creating a small like programming language from scratch. Yeah, yo, Chandan, how is it going? So this is what it's saying, right? So in 17, it should be available. You can search file txt. We have already provided this in our project source, right? Is my spelling wrong? I don't think so. Like it's this, right? The same thing. And I've seen that this works. It's not like this doesn't work. Android equals to C++ 17, so it's right only, I guess. Uh, then why are you not happy with the string view? You're happy with including string view. You're not happy with string. Uh, right. So I ask as to why it's happening. You can also set the blah blah blah. I don't care. I'm not using VS Code. Compile flags work. That in fact no. Alright. So and it's my project root directory, right? So um, is there something for renaming? Copy, delete, remove. So maybe we'll do the trick. Into the new path. It's compile flag.txt only. Just uh, can try removing S maybe. What's the issue? Does that do the trick? No. Yeah, I want to use string view, but not allowing me. That makes me very sad. Mm, but usually this works. So enough now. Yeah. So in fact, we might as well try to open this on VS Code. See what is the problem. You can download the VS Code server for Linux, I guess. Mm. I had doing this setup things, right? So if we see here, right, in Lex.h, it's string view, no problem there. It's compile flag.txt is fine. So why? Why are you complaining that? Yeah, some kind of loading issue. I don't know. But now it works. So with that, we can continue on our journey, and you can have a function which basically loads the entire file and gives me a chunk of these tokens, right? Maybe we can call this tokenize, and it will take a file basically and return me the tokens, something like that, I guess. Yeah, that works. Token is source. So we can have its implementation, right? So basically, std vector, or you can just be lazy and you can just this. You can make this a static, right? Because why not? And you can copy this and paste it here. And remove the static. And yeah, we can it's basically started with this thing, right? And we can already like we can include our utils because there we can load the file, right? So include or like the content will be there because like if I load the file and then I just get out of the scope, then the string will basically be deallocated. If the string is deallocated, then yeah. So in that case, we will just take the source directly. So maybe I will just take the string itself. That makes more sense. So tokenized source code basically takes the source code, not the file. Okay. So whenever we're saying source code, that means the source code, the entire source code as a string. Maybe that can be a convention that we can go with. So std string reference source, right? And this will also be that only. So yeah, std string reference source. Yeah, and basically what we need to do is first of all we need this vector. So std vector, right? We can have an empty vector, and then we basically want to parse the string, right? So you can have some helper functions, maybe like I don't know, something that like skips the white space, obviously. So let's create some helper functions first. Uh, skip white space, right? And its job will be to skip the white space basically, right? So you can create a lambda function for that, which will basically take. Okay, we can go with character pointer at this point, right? Because otherwise we have to take it, recast it to, uh, and just make this as character pointer. It might look a bit unsafe, but that's fine. Yeah, and so we can just give the incremented pointer, right? You can take that pointer wherever the cursor is, and then we can make a check, right? You can check that if whatever the value is equals to, let's say, white space, or maybe is some tab. In that case, we want to basically just increment the pointer, right? Yeah, C++, and this will continue. And once we're done with that, maybe we can just return the new pointer. So I think that works, right? Um, and then we also want to skip the new lines for now. Later we'll check, but for now we don't care about the new lines. That we can think about that later. So the first thing I'd like to do is get looping work. So basically equals to our source, right? And then while is not equals to basically zero or backslash zero, right? Or you can just say that while this exists, right? And maybe I don't know, star C is not equals to EOF. There should be some EOF symbol, right? Then we can keep on parsing the things. And then when we're done, basically, we can return the tokens. Right. So, first of all, it might be like a string, right? And ID, right? That's the first kind that we want to do. And first of all, we want to just keep, I guess, the mm, whatever the white space is, right? So that will be our first step, I guess. Skip white space, and skip white space also takes C, right? So once we have skipped the white space, maybe for now we can also skip the new lines. But in future, I would like to have new lines under like end statement, so that if you forget a semicolon, then also it should be fine. We can check that. For now, we can say that. So star C is actually we can make a uh, function like process new line, something like that. Because sometimes what happens is that you have backslash r backslash n, that kind of scenario. I don't want to deal with it right now. We'll have to deal with it at some point of time. Um, yeah, but for now, we just ignore it. And right now, I will just do a small hack. So C equals to backslash n or backslash r, whatever it might be. I just want you to increment C. Yeah, I'm just incrementing C, so I don't think we need to have a block, and then we can return C, right? So yeah, after processing the white space, I would probably like to process the new line. For now, we can just have these two there. I don't see any issue for now, at least. Some point we'll have, but when we'll have, we'll deal with that. Something like that. This will most likely take care of all the unnecessary characters that we want, and we can get started with the actual thing. And yeah, we missed a semicolon here. My bad. So after skipping basically all the characters, right? The first thing that we want to see is that if we get an underscore or something between zero and like any character, right? Underscore or any character, that means that that's an ID, right? So we can go for that. So we can say if let's say C equals to or is alpha, right? Is alpha our character, right? Or our character itself is underscore. In that case, we want to do something like parse ID, which basically takes the current buffer with the cursor as well as a reference to our tokens, right? Right. And it's basically going to insert that token and update that cursor for us, right? Mm. Or we can have the same way where it gives me the new cursor. Maybe that can also work. So we need this parse ID in this case, right? So uh, actually, I like using lambda functions quite a bit. I don't like need to spread out the things that I only need at one place, right? Um, so yeah, so maybe we have a begin and then we have an end. Then while or it can also be like begin plus one, right? Why not? Um, so in that case, and while we will check the same thing, right? So basically, is alpha AOPJ, if I can spell correct, E, or E is equals to underscore. Actually, it's better that it can also be like alphanumeric, right? So you can use is alpha num. I think there is something like that. Is alnum. Okay, they call it is alnum, but that's fine. So is alnum e in this? We just keep on incrementing e, right? And then we can ask ChatGPT how we can create a string view out of this. So how to create a string view from pointers. Right. So yeah, this works, I guess. So we return our E because we have successfully reached there. But also we create a new token, right? So for now, we can just say tokens dot pushback. And basically our tokens right now has only two parameters. I'd like to have some more parameters I can add. Uh, one might be the line number. Yeah, we can have a line number right now. Let's just have it. Right. And by default line is zero. I can when starting you can have this like currently we are at zero. And now we increment C, but along with that, basically if it's a new line character, right? Uh, then we need to increment the line number. So line plus plus, I guess. And then with that, we now have lines. So we can have the context of whatever is going on here, right? But that might mess up with C down here. Uh, yeah, we can yeah we can have the context. It's fine. Anyways, let's see if anything happens. But for now, it's fine, I guess. So now that we have a line number, and why are you complaining? Okay, you expected this. I also expected this. So the first is a type, right? So it will be like TKID because we're passing an ID, and then the second parameter is the string view itself. So yeah, maybe you can have a string view with b minus b plus one. I don't know. We'll check. And the third argument is the line itself, right? Um, and then a semicolon. So that's about parsing an ID, right? And yeah, pretty much parse ID should return. Yeah, and it should take tokens. But right now, I can remove tokens because it already has access to the whole context, right? These functions, the whole function context. So I can just skip that part. And with that, we have parse ID, right? Next, maybe something like parsing strings. So if let's say our is equals to a double quote, right? Or maybe it's equals to a single quote, something like that. In that case, we can say that equals to parse string, right? And we can copy this thing right here. We can paste it. We can maybe add a line between here. We can call this parse string, right? And here, basically, whatever is my delimiter, right? So the value of C, and then I can just check that while E star E is not equals to delimiter, right? We keep on incrementing E. So E will eventually reach to the delimiter, right? And when that happens, our string is basically actually it will start after delimiter, right? And basically E minus B in this case because we don't actually want the delimiter. If it's not that, if this is wrong, then we'll have -1 here. But we can see that later at some point of time. And with that, we can then do something like increment E for the last time because obviously we need to skip the closing quote also, right? Yeah. And with that, we should be good to go with parsing string. Right. So one thing I thought that I would like create operators and like for example closing brackets and these in a different ways. So we can call them something different. So we can have PKOP. We can have PK something like I don't know punc or punctuations, right? So we know that punctuations are at least in this stage not same as operators, right? We can have like what characters can be considered as operators. So something like maybe something like and it can be like plus minus multiplication, maybe slash for divide and so on. Yeah, maybe we can deal with line comments also. So let's add a function for that. So we can call this something like skip comment, right? So basically when we say skip comment, unless we reach \n, right? While like this is not \n, basically we continuously keep on incrementing, right? Uh, so C++, and then basically we increment the line once, and yeah, we return it, right? So detecting a comment is actually easy. So basically, if for example C0 itself is backslash, uh, yeah, this should be fine. And also C1 itself is also backslash, right? That means we need to skip the comment. Yeah, so maybe that means something's very wrong, but we'll get them right once we compile and run everything. For now, I am not worried about it. So you have parse ID, parse string. Next, we need to parse the operators as well. So right now we have these four little operators, right? So and also this character, right? So that one is equally easy. So I can just do that one quickly. So if star c is equals to mm, this, right? So that means we can just C++ and one thing, these all should be else safe, right? Right. So we can do C++, and then we can basically say that yeah, tokens dot pushback pk end statement, and it's just this symbol, nothing else. Underline, right, and make it like this. Uh, yeah. So that I think works for like the end statement symbol, and we can get that. And the next one I would probably like to have is numbers, right? So you can have something like parse number. If I can spell it correctly. So yeah, our cursor is there. So you can have something like right, and we can say that tk.type is essentially int for now, right? And then while tk dot let's say not tk, but while the character itself is num, it's digit, I think it's called. We need to pass the character. We can have the same thing like the begin and the end, right? And then end. Mm, then I can say that okay, while the end is supposed to be plus one like this. So while we are basically encountering a digit, keep on incrementing the right. So no, sorry, keep on incrementing the end, right? And then if uh whatever the value in our end is right now at this stage, it's not in dot. That means it's an integer number, and we can safely return our token, right? So we can say pk dot I is equals to pk int. Actually, forget about this thing. Leave this here. You can just use the same thing. and you can say that this is an int, right? But and we can just return it. So this is not equals to this, right? And we can check some. We can add some other checks for hex and those later. Right now, I'm not doing that. And then, if we got a dot, that means after that we have some additional numbers, right? So then we basically do e plus plus, because in this case we have encountered a dot. We can just keep the dot, and yeah, this part is identical to this. And then I can simply like return. I'm honestly writing code without checking. That might cause some issue. I don't know, but we'll get all the debuggings done together, right? So now that we have numbers as well, we can implement that here, right? So else if star c, uh, sorry, is digit, right? Star c. In this case, I want you to parse a number for me. So ARSC, first num C, I guess. Yeah. So that goes for number. Then comes our operators and punctuators, right? I'm just naming them accordingly to my wish. It's not that they're strictly actually punctuators. Yeah, I'm just thinking of naming them that way, so that we have a kind of distinguish between normal operators and these operators. We can have everything called as operator. That would also be fine. Yeah, and an important operator I forgot is equals to. Right. But for now, this three should be fine. Right. We can check later. Hmm. While we're at it, let's add some. Because why not? Right. Mm, 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 mm. So we can have a function, right? Something like is operator or something like that, right? So maybe is OP. Maybe it's nice, right? Is OP. So we can have a character. We can have our cursor, right? We can just check if for it should work, right? I don't know. Like I never tried to use like this kind of sort and follow for on like normal edit it works. So I guess it should work. Don't know. I'll know for certain. So if basically our character is like ch, right? So if our character is in fact equals to whatever its current character is, then we can return true, right? So it is an operator. Else we can return false. I think that works, right? Yeah, it will not allow me to do that. So we can add something like maybe we can just I don't know, I never tried it, but bar const expression. Is this a valid syntax? Think so. We'll know for later. So can I do that? Do this const here. OP. char set length equals to str len op. Just set. Can I do this? Yeah, it's of size t, I guess. Do you allow that? Str len for that you can use I think C string. Yeah, so it does not allow me to do that. I have a better idea. Like we have 1, 2, 3, 4, 5, 6, 7, right? So we're stopping us from writing this as 7. That's the most stupidest way of doing things, but for now it's fine. So 4 and then 5, 6, 7. And here also like 1, 2, 3, 4, 5, 6. Right. So yeah. Uh, 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 Actually forgot about it. At this stage we don't really care. We can care later. Or we can yeah. At this stage, let's not care about it. Whatever you are, we support you with our heart. Maybe I don't know. Mm, So like this, right? So 7 plus 6 is I think 13. Wow, I think I calculated that correctly. I didn't know I was this good at maths. But yeah, so we can't do this. But what stops us from doing this? So for character, we can use our OG for loop. So in I is less than OP just length I plus plus. This is less than not M, and then we can just simply check OP just set I, right, and this should be OP, but I have written it as CP. That's fine. Right. So yeah. So this will basically tell us this that if a particular character is operator, at least this is not optimal, but yeah, you can delete it. So obviously then comes our operators, right? So yeah, else if our character like is OP, right? If the character is a OP, right? Then we can do the same thing. Then we can just say C equals to parse OP, right? Let's see. We're following a nice pattern at least. I don't know if this will compile right or not. Uh, but I think we will get some errors that we will need to fix. Uh, but we will see that. So, OP, I guess. Yeah. So, parse OP equals to something like this. All right. And I can straight up start plagiarizing. But here is the thing, like in this case, the ending will start with begin, right? There is no, or it can be like at least we know that the first character is okay. We can, I think, we can do this. It's fine. Then while the same thing is OPE, right? So while basically the E is an operator, right? They would like to increment it. But from now I understand. We should have this differently because see, we can allow a combination of these, right? But we shouldn't allow a combination of these. The combination of these should be separated, right? Yeah. So I was right. This should be seven, and you need to have like something like I don't know, punk, and you can also call it tiki punk. That's why not. Already have tiki punk. So tiki punk, some kind of name like Vegapunk in One Piece. If you see One Piece, Vegapunk, I don't know if he's alive or dead, but yeah, he's the guy now. Everybody is looking at in One Piece. Mm. So, yeah, it's just these guys, right? Dot and comma for now. So there are total eight guys, I think, right? So we can just say that Punk mm, is eight, right? For now, at least, right? And so basically, we can copy this stuff, right? Like this, and we can make this like this punk, for example, right? And the only thing is that this will be like punk, right? And this will also be punk, right? This should be called punk. Uh, just a claim, correct? So why are you complaining? PUNC, yeah. Just go for PUNK. Should be PUNC. That's right. So yeah, let's fix that quickly. So this is punk actually. Like this is also punk, right? But I think at the top also I made it PUNC. Oh no, this is PUNC. Then that's fine. So we can go a bit down, I guess. Somewhere here, and we can have like our parse OP here, right? Which basically does the same thing and then just return this thing. We can even just like make this thing as a macro and push. I don't know. We can use that. That's fine. This amount of code copy is fine for me. Although I'm not like CR four times is fine. After that, I think that it should be its own function. It can be inline, obviously, but yeah, it should be its own function. You don't want to repeat too much code, I guess. So next is auto parse func, uh, and that is the most easy one, right? Because all you need to do is push that particular punctuation, right? So whatever the value of character is at that moment, that one, um, yeah, and we need line here. Yeah, we can just actually just take line. Yes, that's the only one that we're using, right? But apart from that, I think it expects string, not like character, right? So Mm, 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 mm. So one thing we can do is we can just completely, but in that case also that punctuation needs to exist, right? Yeah. So because it's a string, like all we need to do is this, right? And then we can just increment C, right, and return it. So yeah, in that we should be able to parse punctuations as well, right? So we can say else if uh, is punk, right? C, this should be is punk C, then C equals to parse punk C, right? And finally, although it will not reach here, should I increment C? Let's not do that. Yeah, let's not do that. And with this, I think even though we might not be fine, we can get to some place where we can just debug a bit and find out if the find out the problems and get it resolved, right? So I will just have a quick handy function that will maybe go through all this list of tokens and we'll print it, right? So something like static void print, right? Which basically takes this guy, right? Reference, right? And then for let's say for each token in the tokens, it first prints the type, right? So ID will be one, string will be two, and so on. And we can live with that at least for now. So maybe at some point of time we want to just do a better printing. But right now I'm very lazy, so I will just do this. I don't know. We have the type here, so which is basically an integer in this case. So percentage C, um, or percentage should be fine, I guess. Because normally this uses integer. I don't know if I remember. Then I think what's star is I forgot, like n length string is I think dot star s. I might be wrong. We'll see. So we can just search once. Like yeah, dot star s. Wow, ain't I getting good at memorizing things day by day? Yeah, guess so. And then we can have something like first of all the token type, right? So tk dot type. Then we need to cast the size to integer, I guess. So uh, tk dot value dot size. And I don't know why, but like rather than this syntax, now I better like this syntax looks more readable to me, right? And the third parameter can be like the buffer itself. So tk dot value dot what is it called, data, I guess. Uh, so with that we have a printing mechanism as well for our tokens, right? And yeah, I'll copy this, but We don't need this as here, right? Because this is where our declarations goes. So we can have it somewhere at the bottom, right? So like yeah, like void print, which basically takes a standard vector of Lex tokens, right, as a reference called token, right, and prints them essentially. So yeah, that's the print function, right? And we can now test that. Maybe we can go to the main file, right, and then we can include our Lexer, right, and we can say something like at the end of our source code, you can have a next lesson, and then you can print it like a small, like this, a separator kind of thing, and then we can have like std vector of lex tokens. I'll call this tokens, and this will be equals to like cards, mm, tokenized source code, and our source code is our file content basically. So yeah, we are going to tokenize our file content. uh, I think we better call this tokenized source, right? Just make the function size a bit smaller, I guess, so we can remove this as well, right? From here and from here, right? So now essentially tokenized source exists, and tokenized source obviously takes file content dot system, which is casted to a character pointer. It might look a bit ugly, but it's fine for us. Mm, Now we can just say print. We can just print whatever token we got, right? So we can say and we can take these tokens, something like that. Now, if we make this like we get into some kind of infinite loop, right? So let's first try to fix that. So the easy way will be to have some kind of like I, like whatever the position is, right? And I can set 0, and then we can say that okay, every time we just do y plus plus, right? And then maybe mm, we just print percentile b comma I, so that we know that we're not stuck, right? Because I think we are getting into an infinite loop, and we get to know that, right? So yeah, maybe we can just use another tab altogether so that we don't have that kind of issue. Okay, Ubuntu. We can increase the font size a bit. We can go inside. I think Swallow. What did we call it? Sparrow. Sorry. Okay, it should be SP, not SW. Yeah, we can deal with that later. For now, just make. Yeah, and we are going out of bounds. So that's not good, right? we definitely don't want to go out of bounds, right? So fortunately, that one is easy to solve, right? Because we know that this should be the source code's link, right? So you can have something like the source and then maybe size the length. Why not? So this will come here as well. So size length and yeah. So the first thing that I would do is I'll check that that this I, right, this I should never go outside the length, right? So we'll say that if I is greater than or equals to len, then you basically are done. So break from this loop. We no longer need you. Your purpose is served. That's fine. You can call. I can make this as size t as well. Right. There is not that much difference, but essentially, now if we make right, okay, nothing changed. That's strange. That is strange. That is strange. Because we never passed the length, so it actually didn't compile, I guess. Um, yeah, and I didn't. So it takes this right, and it also takes like the size, right? So file content dot length, right? I can spell correctly. Why did we close it? Let's just get the font size a bit smaller. I think the files are saved, right? So we can try to make obviously, and you get something like this, right? So first you get int. Whoa, it's actually compiled, right? So first you get int, right? Then you get add, and this guy, which we should not have, right? And with int also we got a space, right? So yeah, and then we have a, right? But after a, it decided that okay, I'm done with it. I don't want to go any further. That's why that's what we need to get done. But at least we got our first hint. That is like when we are passing this ID, right? We don't need to do +1 because we're starting with b +1, right? And E is going to be the last character after that, I guess. Yeah, like that makes sense. Like if it's the length, right? So basically, whatever the beginning is from that, the end is one character after, I guess. So if we just do that, then in case of string, this should be -1, I guess. And we are only breaking if I is greater than length, right? Yeah, we'll see. So just push it, right? We don't do anything else. Yeah. So now if we compile, right, we get first of all int, second of all after that still this guy is here. But that's basically how our make is written right now. But yeah, so we get int, and then we get add, then we get this symbol, right? This guy, right? Then we get int a, then comma, then b because we forgot to put in, but that's fine. But this right now, Lexing, we are not doing anything else right now, and then we close it. Then we open parentheses like this, and then we have if this, and then we have this symbol, right? This symbol is still not defined, so that's why it uh, it ended there, right? So we can have those as well here, right? You can have this guy, you can have this guy, right? And with that, we should be good to go. And we are successful in like passing a file, I guess. So make yeah, need to make twice because you're stupid. Still, you are complaining about what after A you are not trying to get. Mm, 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 mm. So one thing, I'd like to get the line number filtered as well. So yeah, I'll add a comma here and another like, percentage Z U maybe not Z U but percentage D. I, I can have them in next line. So pk dot line, right? We can have that. Now in the punctuations we have added this symbol, so this will be 9, I guess. Anything else doesn't come into my mind, at least not right now. And yeah, we got a lot of tokens. See, so we need to like look at this side by side, I guess, in order to like verify stuff. So I think we can do that. We can split it. So is there a vertical split somewhere? Um, 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 we can and split to right. Yeah. So we can go to Sparrow and then we can look at the example, right? So whatever our demo code is, if we look at it, right? So it has the last is 21, so that's correct. Line number 21, and it starts from like line number 5. It the first comment is omitted. Then we start at line number 5, which is type 1. Type 1 means that yeah, that's correct. It's an ID. Then we get a type 1 int followed by a and a, which is a type 1. Then we have this punctuation, right? And so on. So it looks good. Except for like when we have a string, like oh, the string we have one less, right? And the string's type is I think given wrong. Yeah, so we need to check that once. I think most of them we have put type as same. But yeah, for string, it's also surprisingly E minus B. This is TKSTR, I guess, for string. This is int, that is correct, but this is float, right? Because you have become a float essentially at this point. And then you have parse OP, which is nothing but TKOP. Right. And then you have TKPunk. With that we should be good to go. If, I don't know. We can make this twice. And the next thing that we need to do is like get this thing. Oh, yeah. So now I think the at least the types are correct and the string is properly getting loaded. This is a string. Nice. So yeah, we created a Lexer and the Lexer does its job. Um, yeah. So maybe we just end this by serializing that data into a file, because maybe what we maybe we don't want to like do everything in memory in future. Maybe we want to store them in a file and then later use them. Right. So in the utils, right, can have something like I don't know, void write file, something like that. And this write to file will basically have a buffer, but along with the buffer, it should also have like for example, I don't know, the yeah, the file, the actual character buffer, right? So, and also you want to have something like how much long it is, right, that you want to write. So size t, length of the file, right? So that will be the signature of the function, I guess. And its job is to write to a file. That's what it's going to do for us. Is this looking good or is this better? I think this that was good. Uh, didn't bother me at least. So yeah, I'm gonna have the same thing like file pointer fp is equals to f open file path. It's time for writing. Not append, but we're going to erase the whole file and write to it. And whatever the buffer is, so basically if write, I'm going to use if write. So if write takes the pointer, and then the size of chunks, how many chunks I want to write, and finally the find pointer, right? That will be easy for us. So the pointer is nothing but our buffer. So PUF, right? And the size is nothing but length, right? Which we want to write. Then finally the no, this will be length. This will be like one. So we're writing one byte at a time. And then we have FP, right? And then we can just close the file. Right? So this is our basically way to write to a file. So what I want to do is after Lexing, in Lexer I want to also have a serializer method. Like in every file I want to have a serializer method in every module, so that at some point of time when I need to like go through the thing without running the program, or have run the program before and just want to match, like compare two files side by side, that will be easy for me. So yeah, in Lexer we can add the serialization and we can call it for a day, because I think we have kind of good Lexing nailed out. After a long time, it was like quite a productive stream from like at least my opinion. So yeah, so let's have that function. Um, so we can call it like serialize, right? Serialize. Not serializes, or all serialize does is it takes this vector, right? These tokens, and it stores them in some file, right? So just file path, maybe const. on Chester. But it doesn't really matter whether it's on Chester or Chester, right? Because at the end, this is just a definition. We can just get this like here, right? And we can copy this guy. We can come to here and we can paste this. We can remove this static here. And yeah, basically we do is we like write the file where whatever our buffer is, like whatever is our file path and then buffer and is right. And our buffer and the length of the buffer, right? So now we need some kind of a big buffer with a big length, right? I know a short trick that might work maybe. So just create a buffer that will be maybe like should I dynamically allocate memory? Yeah, for one for simple work we can do that. So buffer which will be like a large chunk of memory. You can also use new, but like malloc is a bit faster than new, from my opinion, even in release mode. So yeah, I might be wrong, but that's how I want to do it. So yeah, we can have a large buffer which is storing all the data. Maybe like you can have like 4 M times this times this, right? 4 MB actually we can have on the disk itself. So let's make like um 512 MB kind of a very big buffer, right? In that buffer, we will continuously keep on writing, and then once we are done, we can just take the STLN of it, and that will be len. So basically, then we can set that main set, right? And we can say buffer, and we can set 0 to yeah this whole length, right? So something like that. We have this. Once we are done writing to the file, we can basically free the buffer, right? And here we can set the whole buffer to 0. Uh, so it will be buffer size, right? And we can then start writing in that on that buffer, right? So basically, the way that we can do that is go through this tokens, right? This is good. Do that, and you can basically uh, let's printf like what is for s what is its signature like is so it takes a string and it takes a format and then it prints it, but does it like written from where it how many characters it has written? So just is man available in here? That is a good question. So man, because in Linux you have something like a manual for everything. Yeah, we have man, right? And actually in sprintf it returns how many bytes it has written, right? So that's good for us because then I can like have something like int offset is this, right? As printf stuff, where it basically prints to the buffer. You can have a temporary something like char star cursor is equals to buffer, right? So you start at the beginning of the buffer, then you keep on writing on the cursor, right? And basically this thing, right? So you can just yank it and paste it here, right? It should give us the offset, right? And then you can basically just increment the cursor by offset, I guess. I don't know. We'll see. If it does not automatically update by itself, but it shouldn't, right? Because it's taking that pointer. So if it took a reference to the pointer, it could have updated that pointer. If it's taking a pointer, it can't update that pointer. Like it can update the contents of the pointer, but not that pointer itself. So yeah, you can just say that okay, whatever my cursor is, increment it by my new offset, right? And most likely it will fail epically, but that's part of programming stuff. Things fail, then we fix it, fix them. They fail again, we fix them again, and yeah. Mm, So maybe I just want to for now we can just write it in examples folder itself. So um, in future we'll see, but for now it's fine. So SW serialize, we can take the tokens, right? Uh, like this, and then for now we can just write it as um we can write it at like example slash like dot slash. So okay, because it's the start project. So yeah, that's fine. Dot slash example slash like snap dot txt, right? So yeah, we can write. Yeah, I think my caps lock is on. So it should write the tokens to the Lex map. Now, do I want to write like this? Absolutely not. I would not want to write like this. Mm, what I would rather like is to use some kind of symbol by which I can separate. And so I know that okay, this is its type and this is its content, and its content ends here, right? So yeah, that's what I would like to do. Like if you want to go totally inhuman, then I'm going to do will be just like taking the struct and serializing it. Okay, but if you sterilize that string view like that, then basically you will lose the content. You will just have two numbers which basically points to the like whatever that memory location was at that time right now, right then when that the program was running, and whatever the length of the string was. So that's fine. We are writing this string, but we also need to wrap this string inside quotes. That's what I am trying to say. That you need to wrap this string inside quotes. So this can be a good format, right? So we have this line number, and then the whatever the value of that particular token is wrapped inside quotes, which obviously should be escape like this. And then I think there is some advertises going on uh, from let's pick up Adukon, and we can just uh, restart this. Right. So that's fine. But I think this is a good format, right? And then we can just keep buffer here, right? And basically our length is just the length of the buffer. So or at this point of time it's just the cursor. But I would rather use strlen, right? And then write to file. So write to file we declared right in here, right? Write to file, write to file. Maybe just we want to make this static. Actually, we want to have it here, right? Something like that. So yeah, the right to file is there now. We not including? Yeah, we're not including it. That's right. So hash include YouTube, not HTTP. Right. Now we have access to right to file. Right. So we can quit this manual. We can try to make this. First time it doesn't work. Second time it does. But the question is that thing there, which you can go inside examples, right? And you can query. And now we have this Lex map, right? So we can read this Lex map, right? Or you can just open it right here. So Lex map, not this, but Lex map, right? So in Lex map we have our the whole Lex data, right? So one thing that I would like to do is instead of colon, right? So we can go Shift G. We'll reach the bottom. We can use comma, right? And maybe some extra spaces in between, but I don't think that's necessary. Rather, what I would like to do is make this make file. So I forgot, but I think we should have a run command, right? And what run basically does is bin slash swallow, right? And for that, bin slash swallow has to be there. Is this the syntax? I forgot, but you can check. All right. So basically, all will make this stuff, and then run will basically. But if I'm right, then it will run this right. So if we say, like for example, make right, um, no target specific and no make file found. Oh, yeah, obviously because we're in example. But if we make right, so it makes this thing right. And if we say make a run, then it runs it. Um, but my question is that does it compile it when I say make run? So we can make a small change, right? Maybe something like this, right? And then already that run exists, right? So most likely this one it requires source files, right? It takes the source files start.cpp, right? So with that it should be able to run it, right? So yeah, it runs it, and then we can say simply make, which basically makes it, right? So it's one process, but for now I think it's fine. We were able to like get this Lex map, right? So we can open this Lex map once again. But before we do that, let's just clean this namespace. So this is SP actually for Sparrow, not Swallow. We changed the name to Sparrow, I think. But yeah, like if you have some cool suggestion for the name, I'm fine with it. So this should be SP, rather, right? Did I save this? That's a question. That's a good question. I should save this. Yeah, and so we can come to the Mender CVP, and this will be SP from now on. In fact, everything will be SP. we'll make sure of it because right now the project is small, so it will be an easy fix. Later, it will be a pain, right? So yeah, there will not be no SW when when you use SP. Is there any SW in this file? I don't think there is any SW in this file. But in Lex, in Lex we forgot to change, right? So yeah, we got one entry, pew 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 pew, and this should be SP, right? With that, it should make, right? Note passing arguments, blah blah blah. Yeah. So that we need to fix. So an open main, and this will be SP, right? This will also be SP, right? Um, let's keep this open for now, and if we get it made successfully, and then I can say make run, at least for now, right? And voila, we need to say make run, and we get this beautiful output that is not beautiful at all, but it works for now. So yeah, that's it for today, guys. Hope you enjoyed this session and hope this was a bit helpful in order to understand how flexing generally works, right? We essentially created a Lexer, which basically goes through the whatever text you have and it it splits them into some tokens, right? And yeah, the code is pretty clean. So we just have a function for each kind of token or like each kind of variant that we see in that particular code, source code. Like for example, we want to parse a string, then here we are basically taking that uh, whether it's the quote, whether it's a single quote or double quote, and we are checking until we are hitting that same quote again. Until then, we are just taking two pointers, one to the beginning of the particular type of token and one to the end of the particular type of token. Once we have those pointers, we are creating that particular view, that particular so we're storing that reference to that like part of the string, like substring, and we're using string view because it does not like allocate too much memory. It's just like reference to the beginning of the string and just how long it is. That's all it's showing. And yeah, we keep on pushing them. So this is basically our Lex structure, token structure, which currently have the line number and the type of the token it is and the value it has. We can keep on working on this. We can keep on improving stuff. But yeah, I think like this is a good start in general. We were able to parse all the tokens and then we were able to serialize them right in a file, which file is basically this or this one file. I think mm, example slash lexmap, right? Yeah, I'm doing a lot of wrong typing, but as you can see, like this is the source. This was basically the source code, right? And for this source code, we got this, which is the chunking of the correct things, right? You can see, right? And also we are skipping the white spaces wherever it is. We are skipping the comments and so on. So yeah, we were successfully able to tokenize this file into these tokens. So in the next stream, and probably a few streams more, we will get started with the next part, which is parsing this whole thing and creating a tree-like structure, which basically represents our code. We call that AST, or abstract syntax tree in general. So there are many ways of writing abstract syntax trees. I'll just use whatever like I feel like, and we'll start going on from there. But yeah, it was a nice stream, and yeah, so I guess thanks for watching. Although there is only one guy right now. आप क्या बना रहे हो? It came, I think, a few. I don't know when it came actually. I was getting things done, so I didn't see the chat. Yeah, I'm making a compiler. मैं एक compiler बना रहा हूँ, and um, the first step in making a compiler is loading a file, understanding, uh, and loading the file basically and chunking it into something called as a tokens, the individual symbols that has some kind of meaning, right? So that's what we basically did here. So the next part will be assembling these symbols into some kind of a tree, which basically represents the structure of the code. It means the order of the operations and these things, right? So we'll get started with that on the next stream. Till then, bye and have a nice day.